Okay, hello everybody. Welcome to our quickie on mobile Nexuz Health. My name is Raf van Durm and I brought along a colleague of mine, Johan Cloetens. And we are working for the University Hospitals of Leuven at the IT department, naturally. Today we would like to speak about mobile software we are developing for the Nexuz Health medical joint venture. I will first elaborate on that, what that exactly is. Then I will give some high-level idea of the security measures we have to take because we are working with patient data. Then we will go a little bit in depth on the architecture of the typical mobile application we develop. And then Johan is going to demonstrate a proof of concept application, especially for the doctors. We are also developing other applications, but they are not yet in a stage to demonstrate, let's say.
Well, not here, actually.
Not here. So, Nexuz Health is a medical joint venture where the idea is that 14 hospitals all over Flanders collaborate and use the same piece of software that's working on a central electronic patient file. Our hospital is the main partner of that joint venture, and all the software is also developed at our hospital. So centrally we have a patient database, and we develop software for our internal medical users, also for external medical users, so for doctors who are all over the Belgium or the world, and also for our patients. We have a patient portal. As we work with medical data, security is very important. So here's a picture of me when I was young. The idea is that before a mobile application where a user has been logged in using some kind of identification in the form of a badge, an electronic ID, a token or a username together with a PIN code, he has to strongly authenticate himself with a second factor. So we use two-factor authentication. And the idea is that we distribute our applications via the application store, because we're only developing Android for the moment. And we use closed Google Plus circles for allowing people to install our software. Once the software is going to run, actually nothing happens. The software says your combination of device and application is not blessed by the Nexuz Health joint venture. The blessing must be done on our internal network or on another external network where the user is strongly authenticated. The idea is that the user registers his application together with his device, and in return he gets a secret code that is used for initiating the TOTP, time-based one-time password algorithm, for providing the second factor for the authentication mechanism. So the internal application generates a 2D barcode that can be scanned by our mobile applications, and then the application is ready to be used by several users. So every device, every Android device is on the external hostile internet, and if the service layer has to be accessed, we use the Shibboleth authentication mechanism, where the TOTP code together with the identity at the app device combination is sent, and the user can access the service layer. So here is a small overview of the architecture of a typical mobile application. On the left, for me, it's on the right for you, no? Also on the left. That's an Android application where you have a REST client that is talking to a REST service that is protected with our security mechanisms. Another thing is that the data that's on the Android device has to be encrypted. We cannot allow the data to be stored without encryption because it's patient data. This also is the case for the files and the user settings and preferences. They are all encrypted in the application data. Some data is also manipulated by other programs that we develop. Our main program is a clinical workstation. It's a fat swing application, client-server application. And in that client-server application, we also developed some kind of notification mechanism to indicate that the data on several devices is outdated or not. And therefore we use event bus somewhere in the cloud where only the IDs of the things that have been adjusted or published. So the Android client then receives that 123 of type contact has been updated, and he then uses the secure communication, the secure REST communication, to actually fetch the real update. Our applications are also multi-user, so once an application device combination is armed, several users can log into the application and can use the REST service. Therefore, the application data is separated into several silos. Every user has one silo, and in that silo, everything is encrypted with a key only known to the application. Here is yet another security issue, because in a typical Android application, you can ask the operating system, give me something to take pictures. We cannot use that mechanism because if you take a picture with a public picture program, it is stored in public memory, in public data, in public storage. It's not acceptable for patient data. So we always have to do some more work to integrate our own media renderers and capturers in the application. For instance, we have to, for playing video, we integrated the VLC video player in our proof of concept application, so that users can view streamed video from out of our internal network over the secure communication layer. So the proof of concept application we developed for getting our users ready, give them some kind of smell of what's upcoming in the nearby future. We have developed a doctor application, so for doctors, where once they have armed their personal device, they have chosen a PIN code and they use typically their badge, their personnel badge, to activate with near-field communication the login sequence. They can then view their contacts of the day. They can take pictures and record movies of dirty wounds and all stuff of their patients. They can make voice recordings that are sent to the clinical workstation for processing. They can consult their private mailbox. We have a private mailbox principle in our clinical workstation. They can look up patients with a barcode scanner. We also integrated our own barcode scanner because of security measures. And last but not least, we have integrated a proxy of a medical image viewer. And now I will hand the word to Johan, who will demonstrate in real life data the proof of concept app. It's actually a proof of concept, like you say, but on a test environment, so it's semi-real time. Like Raf mentioned, we have several authentication mechanisms. One is a company badge, which we can use through an NFC, but we can also
we can also use the Belgian electronic ID. There are compact adapters like this one, which is almost like a dongle that you can insert in your Android device and which can read your electronic ID. So we're going to the login sequence here. So the application detects that I have an electronic ID. It reads the information from it, and I only have to give my very secure PIN, which is 1234 in this case. And I'm starting the login sequence. Typically at login, the client syncs with the backend to get the latest information. What we have here is a view on this private mailbox that Raf mentioned, where typically reports are sent to, and reports of examination. So our client supports different media types like PDFs, but also movies, audio files, and medical images. In this case, we're viewing a PDF file, which is supposed to be an end report of an examination. I'm going to try to find the video which is not too, well, this one should be okay. And like Raf mentioned, we're adapting open source components internally in the application to make it work with the secure tunnel. Let's see if we can find something else which is not too...
This was not yet a dirty movie.
No, this is very decent. Well, that should be enough to give an ID. We also have a view on the contacts or the patient that the doctor is going to see with some information. He can add pictures. Perhaps I can take a picture of the... Well, let's try this one. Okay. I can then choose to upload it to our backend. I add some metadata to retrieve the information later. We have something like an upload manager comparable to a download manager in Android, which only works basically when there is network connectivity. If there isn't any connectivity, he simply uses the cache, and when the network is up again, he tries to sync it to the backend. In this case, we're seeing that he has done his work correctly and he has uploaded it to the backend. Like Raf mentioned, also the doctor can file a report by dictating basically his report. So we can start to record his report, and then afterwards he can send it to a pool where it is transcribed to text, basically. Okay, has been uploaded as well. We also support viewing medical images, which are typically the CRTs, MRIs, and stuff like that. Let's see if we can... Those kind of images. We're actually embedding a web client here. It isn't really optimized yet for touch, but the upcoming versions are
this is version 2 of the Zero DICOM viewer AGFA. And we are now currently upgrading to version 4 immediately, who has been optimized for touch interface. And we proxy it over our secure channel again.
Well, that's more or less. Well, I could demonstrate how you scan a patient, but we don't have a band with us. So that's basically it for the demo.
Yes. Just in time.
Okay. No time for questions then.
Many questions?
Can you describe more about the process of encrypting database, or just encrypting the file system, and then how do you encrypt the data? What exactly?
Well, we use SQLite and SQL Cipher to encrypt the database, and the files are encrypted per file, basically. And the keys are stored again in the database. That's how we use.
There's a master key for the database.
Yeah. And where we can, we use the credential store to store master keys. Any more questions? Okay,
thank you.
That's it.